Welcome to LEMMATIZATION class. I am your teacher, Jan LEMMATIZATION. Today, we study how to make a simple chatbot using natural language processing. The latest trending development advances in the field of artificial intelligence, particularly natural language processing, provide great conversational interface that allows you to ask questions in natural language such as English. The OpenAI ChatGPT or Chat Generative Pre-trained Transformer offers know-it-all answers on many topics like computer programming, cooking, essay writing, science, culture, religion, geography, history, arts, etc. You ask it, it knows almost everything. While the Mid-Journey AI art generator, you enter text descriptions of the drawing or image that the Mid-Journey AI draws or paints for you. On the other hand, you can communicate via speech or voice to Cortana or Alexa and answers all your questions, as well as give commands to them, and they will obey and take actions. The Natural Language Processing or NLP is a subfield of computer science that is focused on allowing computers to understand language in a natural way, as humans do. Typically, this would refer to tasks such as understanding the sentiment of text, speech recognition, and generating responses to questions. These are some applications of natural language processing, such as AI assistants such as Cortana, Siri, Alexa. Second, auto spell check on smartphones. Number 3, predictive text or text completion. Chatbots that handle customer service requests, information extraction, language translation, and sentiment analysis. Let us learn some methods or techniques in natural language processing. Tokenizing text refers to splitting text into minimal, meaningful units. It is a method of breaking up a piece of text into many pieces or tokens, such as sentences and words. Token is a piece of a whole, so a word is a token in a sentence, and a sentence is a token in a paragraph. For example, the text, the paragraph, "Hello world, it's good to see you. Thanks for buying this book." The paragraph is tokenized into sentences. Like for example, "Hello world, it's good to see you. Thanks for buying this book." And then the sentences are tokenized into words, such as the words "hello world, it's good to see you. Thanks for buying this book." The next method or technique in natural language processing is called stemming. Stemming is a process of extracting a root word. For example, the words fish, fishes, and fishing are stemmed into fish, which is the root word. For example, we have these following sentences: "I like fishing, I ate fish There are many fishes in pond. When these sentences are stemmed, therefore it will look like this. I like fish. I ate fish. There are many fish in pond. Note that in natural language processing, English grammars like singular, plurality of nouns and verbs are not recognized. The next method or technique in natural language processing is called lemmatization. Lemmatization is a process of extracting a root word by considering the vocabulary. Somewhat similar with lemmatization, but there are differences. For example, the words good, better, or best is lemmatized into the word good. The differences between lemmatization and stemming is that the part of speech of a word is determined in lemmatization. It will return the dictionary form of a word which must be a valid word, while stemming just extracts the root word. For example, lemmatization handles matching car to cars, along with matching the word car to the word automobile. On the other hand, stemming handles matching car to cars only. Lemmatization can get better results. For examples, the stem form of lips is lip. Similarly, the lemmatized form of lips is lip. The stem form of lips is lib. But the lemmatized form of lips is left. Note that the word lives is the plural of lip. Note also that the word lives is a verb present singular that means to depart. The next method or technique in natural language processing is stop words. Stop words are very common words that carry no meaning or less meaning compared to other keywords. If we remove the words that are less commonly used, we can focus on the important keywords instead. For example, in the context of a search engine, if you search or query how to develop ChatBot using Python, if the search engine tries to find web pages that contain the terms how to develop ChatBot using Python, the search engine is going to find a lot more pages that contains the terms how and to than pages that contain information about developing ChatBot, because the terms how and to are so commonly used in the English language, and they are stop words. Some examples of stop words other than how and to are the words n, the, disable, either, else, ever, and, or, of, on, and many more. The next method or technique in natural language processing is removing punctuations. This step is very common and very important, as punctuation does not add any extra information or value. Hence, removal of all such instances will help reduce the size of the data and increase computational efficiency. For example, the sentence, the paragraph with sentences, hello world, period, it's good to see you, exclamation point, thanks for buying this book, period. If we apply remove punctuations, it will contain now the tokenized sentences, hello world, it's good to see you, thanks for buying this book, without any more punctuation marks. The next method or technique in natural language processing is bag of words feature extraction. Text feature extraction is the process of transforming what is essentially a list of words into a feature set that is usable by a classifier. Bag of words construct a word presence feature set from all the words of an instance. This method does not care about the order of the words or how many times a word occurs. All that matters is whether the word is present in a list of words. For example, the text, the quick brown fox, when they will be processed by bag of words, they will contain values of either ones or zeros. For example, if there is a present of quick in the vocabulary or dictionary, therefore it will be marked 1. Or even in the intent data set, if there is a word like, for example, brown, and it contains 0, it means that it is not in the list of intent dataset or vocabulary. So 1 indicates the presence of that word in the list of words or bag of words, and 0 is a false. If the word is not in the intent dataset and pre-trained model, then it is 0. The probability of prediction of the response is low. Take note that the word "the" is removed because it is a stop word. The chosen bag of words made up of ones and zeros as features that are used as input to the artificial neural network classifier. Text classification classifies the sentences into multiple classes. The aim of text classification is to automatically classify the text documents based on pre-trained categories. For example, the class greetings contains the following sentences: greetings, hello, hi, good day, what's up, how it is going. It can be words or single word. Another example, the class name contains the following group of sentences: what is your name? What should I call you? What's your name? Who are you? Can you tell me your name? And then we have another class name, goodbye, containing a group of sentences or words such as goodbye, so long, live long, and prosper. In supervised machine learning, the classes or labels or tags or categories are given, and this dataset are used to train the classifier model, and it will learn from these examples. ChatBot is a computer program that processes natural language input from a user and generates smart and relative responses that are then sent back to the user. ChatBot is an artificial intelligence software that communicates to humans either text-based or via voice-based. The artificial intelligence is actually machine learning and deep learning algorithms running under the hood. These are the 4 components of ChatBot. Number 1. Intent is a term used for identifying the intention of the person who is using the chatbot. A chatbot should be able to perform some action based on the intent or query or asking or question it detects from the user's message or query. For example, when a user says book a movie ticket to a chatbot, we as humans can understand that the user wants to book a movie ticket. This is intent for a chatbot. It could be named book movie intent. Note that the intents are used as training data for the chatbot to learn from. Number 2, entities. Intents have metadata about the intent called entities. In the example, book a movie ticket, booking a ticket could be an intent and the entity is movie. Number 3, utterances. Utterances are nothing but different forms of the same question, intent, or pattern your user may show. Finally, training the bot. Training essentially means to build a model that will learn from the existing set of defined intents or entities and utterances or patterns on how to categorize the new utterances. To build or construct a chatbot, this flowchart shows the steps. Step number 1, we identify the topic features of the chatbot. Next step is the intent. We gather the intent dataset as training data. The more utterances, samples you add to its intent, the better the chatbot gets in distinguishing among the intents. Train the bot. Training essentially means to build a model that will learn from the existing set of defined intents or entities and utterances or patterns on how to categorize the new utterances. When we train the system using utterances, this is called supervised machine learning. Evaluate means to evaluate the accuracy of the model trained. Next, test means make prediction. If the result of the accuracy is very low, we need to gather more intent. If the result of the test, the validation test, is low, therefore we can add more intent or classes or tags. Finally, if we deploy our chatbot, here are some deployment platforms that our chatbot can live and can communicate to humans. We can deploy them to the web server, to the Facebook Messenger, to the Slack website, Discord website, Telegram website, and Kik website. To implement the methods or techniques of natural language processing such as tokenizing text, stemming, lemmatization for building a chatbot, we use this natural language toolkit. The natural language toolkit is a suite of libraries and programs for symbolic and statistical natural language processing for the language English, written in the Python programming language. NLTK is intended to support research and teaching in natural language processing or closely related areas including empirical, linguistics, cognitive science, artificial intelligence, information retrieval, and machine learning. To train our chatbot to respond from queries made by a user, we use TensorFlow with Keras library. TensorFlow is a free and open source software library for machine learning and artificial intelligence. It can be used across a range of tasks, but has a particular focus on training and inference of deep neural networks. While Keras is an open source deep learning library written in Python. Today, both of these two are joined together that we can benefit the power and features of both the TensorFlow and Keras libraries. Let us understand artificial neural network for training our chatbot for predicting responses. Artificial neural network is an attempt to simulate the network of neurons that make up our human brain, so that the computer will be able to learn things and make decisions in a human-like manner. Artificial neural networks are created by programming regular computers to behave as though they are interconnected brain cells. So our chatbot can learn from the intent dataset and make responses to the user or person by simulating the network of neurons that our brain is made up to think and analyze. The artificial neural networks has input layer of nodes or neurons and hidden layers of nodes or neurons and output layer of nodes or neurons. It applies forward processing and back propagation algorithms. The type of artificial neural network that we adopt to make a chatbot is the multi-layer perceptron artificial neural network. Multi-layer perceptron belongs to the category of feed-forward artificial neural networks and are made up of three types of layers: an input layer, one or more hidden layers, and a final output layer. More than one hidden layers, we call this as deep neural network or deep learning. I made a simple chatbot named SIGLAT, a BSU or Benguet State University info chatbot. And these are the following scopes. It is a text-based. The queries are written in pure English. It should be able to greet the user dynamically. It should be able to respond queries about the Benguet State University or BSU on the following topics, such as history, vision and mission, courses offered, admission requirements, enrollment, student services. I collected, gathered, and composed the intents that are grouped into tags or classes or categories. Each tag or class contains patterns or utterances and responses. For example, the tag greetings has patterns or utterances such as greetings, hello, hi, good day, what's up, how it is going. And then it has responses such as hello, hello and welcome, how may I help you, what information about BSU do you want? The tag is the class or category. The patterns are the utterances. When there is a high probability of prediction, the chatbot will randomly select its response to the user. For example, if the prediction matches with that greetings, and then the responses are so many, therefore it will randomly pick among these responses that will be the response to the user. As of this date, the number of tags or classes in the intent dataset is 23. This is subject to change when I keep adding or removing tags or classes. The cases of words such as capital and small letters are distinguished by the NLTK library as different words, not the same. Therefore, I set all patterns and tags into small letters, except the responses that can be written in capital or small letters. The user's entered intent is converted to small letters before predicting the response of the chatbot. This is the physical design of the multi-layer perceptron neural networks of SIGLAT, a Benguet State University info chatbot. It has an input layer that consists of 99 chosen words as bag of words, which are turned into ones and zeros. Next, it has 4 hidden layers. The first hidden layer has 128 neurons. The second hidden layer has 128 neurons. The third hidden layer has 64 neurons. The fourth hidden layer has 64 neurons. Next, it has an output layer that consists of 23 neurons because there are 23 tags or classes in the intent data sets. The tags or classes of the intent dataset will turn into bag of words made up of zeros and one. The output layer contains of 23 classes or tags, and these are the output, the result of the feed-forward and back propagation algorithms being done in a multi-layer perceptron artificial neural network or deep learning. This is the logical design of SIGLAT, a BSU info chatbot in user's point of view. The artificial neural network will accept a user's query, for example, what courses are offered at Benguet State University, and it will predict the chatbot's response. For example, there are many courses offered at BSU, such as information technology, and so on and so forth. So the train classifier model of the multi-layer perceptron neural network or deep learning will process the user's query and determine the predicted tag or class as response to the user's query. Let us open up the file name intents.json. The file contains the intents data set, and it contains 23 tags or classes or categories. Every tag has a group members containing the patterns or utterances and responses. For example, the class or the tag or the category greetings contains the following patterns such as greetings, hello, hi, good day, what's up, how it is going, how are you, and then the responses are the following, hi there, how can I help you, hello and welcome, how may I help you, and so on and so forth. These are the gathered data that I collected and composed, and then they are 23 tags all in all about BSU, information of Benguet State University. Let us open up the source code file, which is training.py. At line 32 to 35 are common Python Python libraries such as random, JSON, or JavaScript object notation, load, the pickle, and numpy. Next, we import the NLTK library. Next, we import the TensorFlow with Keras library. At line number 46, it uses the WordNet vocabulary of NLTK library to be used by the lemmatizer or lemmatizing technique in natural language processing. At line number 49, it will read the JSON file that has a file name intents.json that I opened up previously. The following lines of code are memory variables that are list, which are empty. And then the variable ignore underscore letters are the punctuation marks that will be removed from the intents. At line number 58 to 69, it will gather the words and classes from the intent data set from the file intents.json. At line number 72 to 73, it extracts the root word by considering the WordNet vocabulary of NLTK, and it will apply lemmatization. At line number 78, it will save the tokenized words into the file named words.pkl. At line number 80, it will save the classes or categories or tags into a pickle file named classes.pkl. At line number 83 and 84, it prints the classes or categories or tags. At line number 86 and 87, it prints the tokenized words. Next, at line number 93 to 98, it will create or make the bag of words from the gathered tokenized words and classes, and then it will turn them into a bag of zeros and 1, and they will be used as training data. At line number 109, it will declare a variable train underscore x that will contain the bag of words made up of 1 and zeros, and that will be the features. At line number 112, it will declare a variable train underscore y to contain the outcome, which are classes or tags made up of ones and zeros. At line number 116, it sets up the neural network multi-layer perceptron model using sequential API. At line number 118 is the first hidden layer that contains 128 neurons. And we need also to supply the shape of the input, which is the train underscore x variable that contains the bag of words made up of ones and zeros. At line number 121 contains the second hidden layer that has 128 neurons. The third hidden layer is at line 123, containing 64 neurons with activation ReLU. The fourth layer is at line 125, and it contains 64 neurons. At line number 127 is the output layer, and it contains 23 neurons because there are 23 classes or tags as of this date and time. And it is subjected to change if I keep adding or removing the contents of the intents data set. At line number 132, the optimizer is the stochastic gradient descent, or SGD. At line number 134, it compiles the model with a loss categorical cross entropy, and then the optimizer is stochastic gradient descent or SGD, and the matrix is accuracy. At line number 136, it trains our multi layer perceptron artificial neural network model, and it will fit the training data with epochs of 200 and a batch size of 5. At line number 138, it evaluates the model. And then finally, it will save the model to the file name chatbot model.h5 file. Let us run and test. Let us open up the file name chatbot.py. At line number 33 to 36 are Python libraries needed in our chatbot. At lines number 38 to 40, it will set up the Colorama library of coloring text in the console window. At lines number 43 to 50, it will turn off messages by the TensorFlow and Keras libraries. At line number 53, it will clear the console window. At line number 56, it will import the NLTK library. At line number 59, it will import the TensorFlow with Keras library. At line number 62, it will use the WordNet vocabulary of NLTK library, and it will be lemmatization. At line number 64, it will read the JSON file, the file name intents.json containing the intent data set. At line number 67, it will open and load the saved tokenized words in the file name words.pkl or .pkl. At line number 69, it will open and load the saved classes or categories or tags in the file name classes.pkl. At line number 72, it will load the train multi-layer perceptron neural network that was saved after the training of the model to the file name chatbot model.h5. This file will be loaded, and it will now be the model to predict the responses to the user's query. At line number 75 to 78 is the function or method that tokenizes the sentences into tokens, or words and applies lemmatization. At line number 81 to 88, the method or function bag of words converts the tokens into a bag of words made up of ones and zeros. At line number 91 to 101, the function or method name predict class predicts the class or category or the tag of the input bag of words made up of ones and zeros. At line number 104 to 111, it randomly picks a response from the predicted class or category. At lines number 114 to 120, it will set up a Control-C keyboard interrupt handler. At line number 123, it will register the keyboard interrupt handler for Control-C keyboard key. At line number 126, it will seed the random object. And then finally, at lines number 129 to 139, the user's query will be accepted by the chatbot uh, by using the keyboard to type or input, and then the chatbot will predict a response. So there will be a interaction between a human and a machine. Let us run and test. That ends our topic for today. I hope you are inspired in my class. Thank you for watching. God bless us.